All right, a hydraulic jack has an output cylinder with a 5.2 centimeter bore, right? So the radius, the output radius is going to be 0.026 meters, right? And needs to lift, this is our output force, right? So the output force, FOUT, is 53,400 newtons, right? And we need to lift that weight with an input force of 356 newtons. So our input force, fin, is 356 newtons, right? And then ultimately what we want to do is we want to figure out what that radius, that input radius is, right? And then since it's the diameter, right, we're going to have to multiply that by 2. But let's figure this out here. Okay, so the input equals the output. So force over area equals force over area, right? So 356 is our input side over the area is equal to 53,400 divided by pi times 0.026 squared. All right, so let's solve for this a, right? I think what I'm going to do is I'm going to start with this guy here. I'm going to go 356 times pi times 0.026 squared divided by 53,400. I think I've got what the area is, right? So the area is 1.4158 times 10 to the minus 5th square meters, right? And then I can figure out the radius and then the diameter, right? So 1.4158 times 10 to the minus 5th is equal to pi r, and this is our input, right, squared. Okay, so I'm going to divide that by pi. And that's what r squared is, and I'm going to raise that to the 0.5, and I get that our input radius is 0.00212289 meters. Multiply by 2 to get the diameter, right? And I get that it's 0.00425457 meters, which is 0.42 centimeters, right? It's about the whole thing, right? That would be a tiny cylinder, right? It's 4.2 millimeters across, right? So maybe make this one a little bit bigger, okay?